Hello everyone, welcome to StudyIQ. So we will continue our discussion on speed distance time. So far we have completed 2 sessions. Okay, so this is the third set. So our discussion on speed distance time. So we have seen the concepts of average speed, then we have discussed about product constancy rule and associated questions also. Now here, okay, let me start off with a question which you can solve by using product constancy rule. You may have other methods also, but once you understand this method, that's going to be very easy for you. Okay, so let me give you a question. Okay, take 1 minute and solve this question. Okay, I hope all of you got the answer. See here, what you need to see is they are talking about a story, right? 3/4 of the usual speed. Okay, so if you see in the previous session, we have discussed about a question where you are traveling at 4/5 of the usual speed. Then I told you there is actually a reduction of 1/5 in the speed. So time will increase. That's what we understood in the previous case. So here 3/4 of the usual speed means there is a 1/4 decrease in speed. Speed is decreased by 1/4. So time taken will obviously increase, and they have given that you are 45 minutes late. Okay, so because of that you are 35 minutes late or 45 minutes late. Now the other story is to make the question difficult. So if the accident happened after 10 minutes or 10 kilometer further, it would have 35 minutes late. So whatever it is, this 3/4 of the speed is what you are traveling. In the first case after 50 kilometer, and in the second case after 60 kilometer. In the first case you are 45 minutes late. In the second case you are 35 minutes late. Let's try to understand this situation like this. So let's suppose this is the first journey. Okay, and the accident happened after 50 km, and after 50 km you are traveling at 3/4. That means there is a reduction of 1/4 after 50 km, and you are 45 late. Okay, so I hope this is clear. Now let's take the second case. Second case is like this. You travel 60 kilometer in your original speed. After 60 you met with an accident. Then you are traveling at 3/4 and you are reaching 35 late. So now what is asked? Find the usual speed. Find the usual speed means this 50 kilometer by what speed you travel, or this 60 kilometer by what speed you travel. That's what your usual speed, right? After the accident you are not traveling at your usual speed. Now what is speed? Speed is equal to distance by time. Okay, so if you know the distance and time, then only you can get the speed. Now how can you solve this question? See, there are many other methods also, but all those methods are going to make this question complex. Let me use the method that we have already learned, which you can apply across topics. That's our product constancy rule. You have seen already there is an increase decrease story here. Okay, so wherever you can find increase decrease story and you can write something as AB equal to C, you are going to apply product constancy rule. So here there is a decrease in speed, so there will be an increase in time. So that's what given here, and that's exactly what given here. But the question here is slightly difficult and different. But again, how will you solve this? If you look at this, if you take this as a common point, see, this is 50, here the speed is same, this is common point, so here you are traveling at the original speed. Okay, now that means up to 50 in both cases you are traveling at your original speed, up to 50. Then if you see here, after 60 also, in both cases you are traveling at the same speed, not your original speed, but a different speed, which is 3/4 of original. So after 60 also, in both cases you are traveling at your same speed. Okay, not original speed, 3/4 of the speed. So up to 50 and after 60, the cases are same in both situation. Okay, so up to 50 in both cases you are traveling at your original speed. After 60 in both cases you are traveling at 3/4 of the original speed. So you can see a difference of 10 minutes, and this difference of 10 minutes is made just because of this 10 kilometer. Something happened in between this 10 kilometer, and that 10 kilometer is what actually made this difference of 10 minutes. Okay, so you can see up to 50 and after 60 is same. So this 10 kilometer is what actually making the difference. So let's pick that 10 kilometer. Okay, let's pick that 10 kilometer. This is 10 kilometer, the first case. Okay, this is the same 10 kilometer. Second case. In the second case, in this 10 kilometer also you are traveling at your original speed because accident does not happen. But in the first case you are traveling at 3/4. Okay, so here you are traveling at 3/4. Okay, and because of that 3/4 of the speed, you are late by 10 minutes. Why I am writing 10 minutes? Because here I can see 10 minute change. 10 minute change only, because see, before 50 and after 60 is same. So the difference is actually made between this 10 kilometer and the difference in time is actually 15 minutes. So that 10 kilometer, if I reconstruct like this, when you're traveling at 3/4 of the original speed, you're 10 minutes late. That's it. 3/4 of the original speed means you're traveling at 1/4. Now the question is reduced to this much only. 3/4 of the original speed, you are 10 minutes late. Like yesterday I've told you 4/5 of the original speed, you are 10 minutes late. Here 3/4 of the original speed, 10 minutes late. So 3/4 means how much reduction? 1/4 reduction. Okay, 1/4 decrease, we know that will lead to 1/3 increase, because 1/x decrease will lead to 1/x minus 1 increase. So 1/3 increase will be there in the time, and that is what given us 10 minutes. So 1/3 increase on time is given us 10 minutes. So time will be 30 minutes. So if you travel at your original speed, you will take 30 minutes. That means in this case you take 30 minutes. But here 10 minutes late, that means you are taking 40 minutes. Okay, and this 10 minutes is the difference which is made here. I hope that is clear. Okay, now what is the question which is asked? Question is speed. How can you find the speed? See, we know this is the original case, right? Here there is no accident. We know this distance as 10. We know the time taken for the journey is 30 minutes. So the answer for this question is 10, which is the distance, divided by 30, which is in minutes. So I need to convert into hour by dividing by 60. So what you get? You get 20 kilometer per hour as the answer. I hope this is clear for all of you. See, what we are doing is, the question is slightly difficult, or you can at least categorize it as a moderate question. So because two different scenarios are involved, an entirely different question is asked. But when you understand in this way, up to 50 and after 60, both cases it is same. Then the difference of 10 minutes is made just because of this 10 kilometer journey. And what is actually happening, that 10 kilometer journey, I'm reconstructing like this. That 10 kilometer I'm reconstructing like this. Okay, so one is the original case, this is the original case, this is the second case. In the original case, you are taking 30 minutes to travel that 10 kilometer if it is in your original speed. But since the accident happened in this case, you are 10 minutes late. So take 40 minutes there. Okay, so see, if the 3/4 of the speed you can find by taking this situation. Distance, that is 10 divided by 40/60, you'll get the 3/4 of the speed. But what we need, this is speed. So that's why I've taken 10 divided by 30/60. I hope this is clear, and 20 kilometer per hour is the answer. So it's up to you to categorize this question as round 2 or round 1. But if you use this method, this is going to be a round 1 and must attempt question. If you try to solve in any other way, this is going to be a round 2 question. Okay? But even if you solve it in round 2, must attempt, because you'll get a sure shoot answer. Now, next we will move on to questions related to trains. Okay. Now, if time permits, I will discuss about escalators also here. Why? Because trains and escalators both are same. Train is moving horizontally, like this, two trains are going opposite direction. And if you look at escalators, escalators are moving like this. And in case of escalator, generally only opposite direction cases will be there. But in case of train, same direction, opposite direction case will also be there. But the fundamental difference is escalator is moving vertically and the train is moving horizontally. Relative speed is applicable there. Meeting point is applicable there. Instead of compartments in trains, okay, instead of compartments in trains, you will get steps here. You will get steps here. Okay, so all these things we'll discuss. But let's try to understand the concept of relative speed first. Okay, then we will try to talk about train. Then if time permits, I'll also discuss about escalator, or I'll keep escalator for the next session, and then I'll discuss escalators along with boards and streams. Okay, so that's the agenda. Now before we start, let me tell you about the relative speed concept. Okay, see, two bodies are moving in the same direction. It can be two person, it can be two bus, two car, two train, or whatever it is. You are moving in the same direction. Okay, so this is moving at speed 1 and second is speed 2, same direction. What is the relative speed? S1 minus S2. Okay, S1 minus S2. That is the relative speed. If two are moving opposite direction, this is S1, this is S2, two speeds, then the relative speed is S1 plus S2. And that's the reason why when you are going in a train and you see a train overtaking which is moving in the same direction, you won't feel much speed. But if you see a train which is coming in the opposite direction, you can see the speed is doubled. Okay, so that's why, because of this, S1 minus S2 is the first case, S1 plus S2, both speeds are added in the second case. So this is a concept of relative speed, and this is exactly the same thing that you will apply in boards and stream also. Let's suppose the speed of the boat in still water is x, but if there is a stream, okay, and if you are moving upstream, you can see you will take or you will feel a lot of difficulties. Speed will come down because of the influence of the stream. So when you are moving upstream, you are moving against the stream, x minus y. And y is what? The speed of the stream. X is what? Speed of the boat in still water. If you are moving in the same direction as that of the stream, if you are moving towards the stream, okay, so then x plus y, you will feel more speed. When you are swimming or when you are going in a boat, you can experience this. And that's a concept of relative speed, and that's what exactly you need to use when it comes to train related questions. Now let's look at the possible questions that you can get from trains, okay? Okay, so let's take a first case. You have a train A, okay, with length L1, or let me mark it as train 1, okay, train 1 with length L1 and with speed S1, okay. So length is given, speed is given, and you have another train, that train 2, length L2 and speed 2, okay. This 2 is what given. Now the fundamental thing is what you need to use is distance is equal to speed into time, okay, or speed is equal to distance by time, or time is equal to distance by speed. These are the three formulas that we need to use, and we will use it interchangeably as per the situation. Now what are the possible questions? Two trains are moving in the same direction, okay, A and B train or 1 and 2 train, okay. Let's suppose now how much time it will take, okay. So L1 and L2 is moving, so the question will be how much time L2 will take to overtake L1, or how much time L1 will take to overtake L2. So obviously the train which is going to overtake the other train will have the more speed. That is clear, right? So if let's suppose S2 is more, okay, the question will be how much time train 2 will take to overtake train 1, okay. So train 1 is moving like this. This is train 1 with length L1 and S1 is the speed, and train 2 is going to overtake. So when I say overtaking, that's the concept that you need to know. I should start overtaking from this point, okay. So, and it's not when I'm reaching here, when the engine of the train or the front part of the train which is reaching here, I can't tell that it is overtaken. I can tell that train 2 overtook train 1 only if train 2 come out of train 1 completely. That is the situation. This to be train 2 and this to be train 1. In this situation only I can tell that the train 2 overtaken train 1. In this case, what is the distance covered? You have to cover this distance and you have to cover this distance totally. So the length of train 1 and train 2 you need to cover. So the length is L1 plus L2. The distance that you need to cover is L1 plus L2, okay. And what about the speed? Speed, since you are moving in the same direction, relative speed is S2 minus S1, okay. And that you will get time taken to overtake by the second train, okay. So first train will be overtaken by the second train because second train is having more speed, so the time taken will be like this. Time is distance by speed. So what is the distance? L1 plus L2 is the distance. That's the point that you need to understand. When you say overtaking another train, two distance have to be covered. Speed is relative speed, okay. Now the same case, two trains, okay. Now instead of going same direction, if they are moving in opposite direction, okay, if they are moving in opposite direction, the distance that you need to cover is the same, L1 plus L2, two train, the distance will be addition of two trains, okay. So but the speed will be S2 plus S1 when you are moving in the opposite direction, okay. So two cases that I have discussed is length or the distance is L1 plus L2, okay. In the same direction, S2 minus S1. In the opposite direction, L1 plus L2 divided by S1 plus S2. So same direction and opposite direction, overtaking a train by another train. One case, okay. So I hope this is clear. Now let's take the first case itself. L1 plus L2 divided by S1 plus S2. That means you're traveling in the opposite direction, you will get time. Now when you make question, an examiner can make questions on anything. They will give you length of the second train, S1 will be given, S2 will be given, and the time will be given, and you will be asked to find L1. Then what you will do, you take this together to right hand side, okay. So T into S1 plus S2, that calculation you can do easily, divide minus L2, and that you need to do as per the demand of the question. They may ask about this also, so this will be given, so based on that you need to find the answer. They can give you anything out of this 5, and one will be unknown, and based on that you can expect a question. I hope this is clear. Okay, now next type of question will be, you are moving in a train, okay, and there will be a post or a pole or a person standing. Okay, so you are moving in a train with length L1 and speed S1, length L and speed S, because this is not a train, right? So this is object with negligible size. Okay, so either a person or any object. So the time taken to overtake this will be, its time means distance by speed. So distance in this case is actually, you will start overtaking at this point and you need to come out of the object completely. So the distance is actually the length of the train. So L by speed. So the time taken to overtake an object which is having negligible length is length of the train by speed of the train. Now this value is not important for us. Length of the train is the distance by the speed of the train. Okay, I hope this is clear. Now the third possibility is, you have two train again. This is L1 and S1. Another train, okay, L2, S2. But this train is standing. This is not moving. Then there is no concept of relative speed. So this S1 will not be there. This is not moving. Only length. That is standing in the station. Now this is moving. So time taken to overtake. Time will be distance by speed. So distance will be two trains, right? L1 plus L2 divided by what is the speed? Only one speed. There is no relative speed. That is speed of the second train when the first train is standing. Okay, so that is another category of question. So this is the case where the train is standing. Now instead of two train, you have a tunnel. This is a tunnel. Then the train is coming with length L and speed S. The time taken to come out of the tunnel. That means what is the distance you need to cover? The tunnel length is also given, LT. So you need to start from here. You should completely come out. Completely come out means length of the train L, length of the tunnel LT. So what is the total distance you need to cover? L, that is the length of the train and length of the tunnel. But what is the speed? This is only moving part. There is no relative speed, so speed of the train. So if you need to overtake a tunnel, length of the tunnel plus length of the train divided by the speed of the train. If you need to overtake an object with negligible size, length of the train by length of the speed. If you need to overtake a train which is standing, which is very similar to the tunnel. Train standing and tunnel is actually same, because when the train is standing it is having only length, there is no speed. Tunnel is also having only length, no speed. And in both case, this two length, that is the length of the train and length of the tunnel. If the train is standing, the length of the standing train and the length of a moving train divided by speed of the moving train. So a tunnel case and the train which is standing case, both are same. I hope this is clear. Now another tricky question will be, see, two trains are moving. Okay, now the question will be, see, the first case that we have discussed earlier, how much time it will take to overtake train B by train A. That is, a train is overtaking the other train. Now I'll change the question, how much time it will take for a person sitting in A to overtake train B. Okay, that means what is the distance you need to cover? See, the person is sitting in train A. Okay, the person is sitting in train A. That means, now let's take two scenarios, moving in the same direction or moving in the opposite direction. So let's suppose you are moving like this. Same direction means this person will start overtaking the train from here, and when this train moved and when he reached this point, the overtaking is completed. So what is the distance you need to cover? The distance that you need to cover is length of the other train. I hope this idea is clear. Length of the other train. So the distance that you need to cover, if a person sitting in other train to overtake another train, the distance you need to cover is length of the other train, and the speed depends whether you are traveling in the same direction or opposite direction. Okay, so if you are traveling in the same direction, S1 minus S2. If you travel in the opposite direction, S1 plus S2. But what is the distance? That's the point that you need to be very clear. You don't want to add two distance. You just need to consider the distance of the other train. You can just imagine you are sitting in one train, and the question is how much time you will take to overtake the other train. So the overtaking will start when you reach at the back of the train, and when you reach at the front of the train, that overtaking is over. That means the length of the other train is what you need to take as the distance. Speed, obviously relative speed. But if the question is about you are again sitting in a train, the time taken to overtake a standing train, then what is the length? Length will obviously again the same, that is the length of the other train. Length of the other train. But there is a change in speed of your train, because you are moving. and the other train don't have speed. Okay, so if one train is standing and you are sitting in the moving train, if you need to overtake the other train, okay, the distance you need to cover is again the length of the other train, because when you reach at the back of the train, the overtaking start, and when you reach at the front of the train, overtaking is over. So the length of the other train is your distance, and what is the speed? Speed of your train. In the previous case, both trains are moving, so relative speed. If it is same direction, S1 minus S2. If it is opposite direction, S1 plus S2. Here one train is standing, so length of the other train remain the same, but speed of your train. Okay, so these are the possible questions that you can expect from this. So either it will be like this: two trains are moving in the same direction or opposite direction, so the time taken for a train to overtake other train. So time taken for a train to overtake other train. Okay, now second question: time taken for a train to overtake a standing train. And that same question can be asked as a tunnel also. So train to overtake or come out of a tunnel or standing train, both are same. Third possibility: so in the first case there is a use of relative speed because both were moving. In the second case, standing train and the tunnel, no speed. Okay. Third possibility: time taken by the train to overtake an object with negligible size. That means the distance is, so object with no size, negligible size. Okay, so in this case L1 plus L2 by relative speed, so it can be S1 plus S2 or S1 minus S2. In the second case also L1 plus L2, but only one speed. Okay, now in this case, what is the length of the train? Okay, length of the train by divided by speed of the train. That's it. What is the fourth case? Time taken to overtake a person sitting in one train by the other train. Okay, so the person or a bird sitting in one train, the other train. I hope you understood. I'm not writing it. So the length of the other train, that is the distance, length of other train, and the speed will be either S1 minus S2 or S1 plus S2, and this you can get as a second choice when the train is standing. Okay, or a bird sitting in, or like this also. Let's suppose you have a tunnel, a bird sitting in the top of this train, okay, somewhere here. The time taken for the bird to come out of the tunnel, then what is the distance you need to take? Distance of the tunnel. You don't want to consider the distance of the train. So this distance divided by speed of the train. This is clear? Okay. Now take a look at this question, just a 10-second question. That's it. So here they are asking about the speed. Okay, so we know speed is equal to distance by time. So distance is basically the length of the train itself. We already discussed this because this is pole, okay, crosses a pole with a that is having negligible length. So distance means the distance of the train or the length of the train, that is 200 divided by 8 seconds. Okay, so 200 meter by 8, that means you will get 25 in meter per second. If the option is given like this, you can do it like this, or 25 into, you need to convert into kilometer per hour, so 18 by 5, so 90 kilometer per hour. So that is the speed of the train. I hope this is clear for all of you. Okay, take a minute and solve this question. We have already discussed about this. See what is given. A train crosses a man traveling in another train in the opposite direction. So these are keywords: man traveling in another train and opposite direction, and the time is given 8 seconds. However, the train required 25 seconds to cross the same man if the train travel in the same direction. Okay, so two different cases given. If opposite direction, 8 seconds, opposite direction means speed 1 plus speed 2. Same direction, speed 1 minus speed 2, that is 25 seconds. Okay, length of the first train is given 200 meter, and the train in which the man is sitting is also given, that is 160 meter. What you need to find is the speed of the first train. Okay, so how will you proceed? So you need to apply the things that we have discussed, and finally what you can get is, if you consider this as S1 plus S2, you can get it as 25, and then S1 minus S2 as 8. Okay, so this is what you will get in the end. So here, which length you need to use? You need to use the length of the other train. The length of the train in which he is sitting is irrelevant data here. That's not required for us, okay? Because that person is overtaking, and we know the person sitting in one train overtaking means length of the other train. So when you use those ideas which we have already discussed, what you'll get is this. And then from this you can get S1 as 33 divided by 2 meter per second. When you convert this into kilometer per hour into 18 by 5. So I hope you will do this, 59.4 kilometer per hour, and that's your answer. Okay, so the point is the man sitting in one train overtaking the other train. So what is required is length of the other train. That means this train, okay, because this is irrelevant. This 160 meters is irrelevant because in that train the man is sitting. So the distance covered is the length of the other train. So 200 is what you need to use, right? So 200 divided by S1 minus S2. Okay. So that is the first case, S1 minus S2, and second case 200 divided by S1 plus S2. So finally you'll get 59.4 km per hour. Very easy question if you know the concept.